Hello sir, my name is Abhishek Kumar Kaur. My roll number is MEP 19002. Today I am here before you to present you the solution of the problem statement 4 of the end term examination of the spring semester 2022. The problem statement states that model and perform finite element analysis of a crane hook using a suitable software package. So for modeling purpose, I am using Solidworks and I will try to do the analysis, the finite element analysis in Ansys 2022, the student version. Now I would like to sketch. So select the sketch option and select the front plane. I click on this center point arc. I try to draw an arc from this point at the origin. Try to again draw a concentric arc with a larger radius and the origin. There it is. I would like to specify the dimension of these two arcs. So I give it as 45. The units have been specified mmgs, so it's millimeter. I specified to be 95 of course. I exit it. Now I want to draw the center line from the origin. From the center line. Now I would like to connect the center line and the two arcs by 3-point arc as I'm showing it here. There it is. And now like to specify the dimension as well. I specify it to be as 44, let's say. Let's take it as 50. I guess I have to make this again. I can specify the dimension as 4, let's say. This one is 95, let's say. Okay, now I would like to extend this. Oh, let me make these points coincident with this line. This point coincident with this line. Now I would like to extend this into the other half of the center line, as in this case. Okay, and now I would like to make this point, this line, this point to be symmetric. Now I would like to extend this part of the drawing. Yes, let's take this 3-point arc, try to sketch it from this point onwards. looks like it. Specify the dimension of this line. Let's take it as 76 units. At this point, these are the radius of the curvature to be 76 again. And we'd like to draw a circle. This part. Draw the side, the radius as let's say 12, and then yes, I try to make it this circle tangent to this line. This circle, this line. Now I want to make this circle tangent to this line. So here I made it tangent to this line, and then I want to make this circle tangent to this as well. So now I made it tangent. So now clicking on the center of the circle, you can alter its dimensions as like this, and we want this point to be a tangent over this circle. So we zoom out, and we want this origin and this center to be in a horizontal path. We want these two centers also to be in horizontal path. To make this point a tangent, this point also is a tangent. So here we are. Next, I would like to trim off some lines. This one, this one. Then I would like to draw the center line from here, this point to this point, and from the midpoint to perpendicular. I enlarge it, zoom out. And I trim off this part. I then draw an arc with these 2 points, mainly because I want these two surfaces to be different. make this lines tangent towards mainly. I draw the center line that is incomplete at this point. I draw a center line between this point, then another center line directly along the vertical axis. This point to this point. We already have an existing center line here. So now the sketch is over. Like the sketch to be in 3D. And now I think I made some mistakes, so I sketched the 3D drawing again. I just changed the orientation a bit just to see it from a different angle. Then now I try to draw the surface. I choose the plane to be YZ plane. So here also I want the circle to lie in the YZ plane. Also I want it to be in YZ plane. Here it is. I've got my surfaces, so now I can move on to 3D sketch. 3D sketch. Now I want to give the boundary surfaces. Click on this surface, tick the surface, tick it, this surface, tick it, surface, tick it. Now in direction 2, click on selection manager, this surface and this surface, and this, okay. Delete this part. Again I click on selection manager, this part and this part. So here it is. Okay, now I want to hide it, and again click on this boundary surface. Okay, now in fact I don't want to hide it. I have to again give the boundary surface. So this surface, I tick it, and this surface, I tick it. Now in direction 2, selection manager, this surface, tick it again selection manager, this surface, that surface I take it. So here is my full body of the crane hook. Hide it, so I've hidden it. So now I want this surface to be a planar one, so I click it, and I want to knit the surface. So here it is. Create solid. Here it is. And then here I want to draw a concentric circle. I'd like to specify the dimension of this circular shape. Let's take it to be 38 units. And now I have to extrude the base out. Let's take it to be 100 units. So this is the extruded portion, and then apply fillet, chamfer, chamfer, mm is what we are designing for as the chamfer part. And lastly, I would like to insert so lastly I would like to insert notation cosmetic thread, M24, this part, line, and this is, let's say, 70 units. and though we have applied it, insert a circular model edge. Okay, so here we have done it, but still it's not showing. So these options and display. Okay, so here where we want to view the cosmetic thread, so click on options and detailing, shade cosmetic threads. Okay, here it is. So with this I have concluded the modeling part of the crane hook. Next we will see the analysis part. So moving on with the analysis part, I've opened the Ansys workbench. I click on static structure because we are to do finite element analysis. The engineering data is already there, so I'd like to now import the geometry directly. Import geometry, browse. Here it is. I've got the tick mark here, so I'd like to now edit the model. So starting, as you can see, the computer is taking some time to open up. The window is my screen, and here is my model. Now I'd like to generate the mesh. And the element size, I can alter it. Also the sizing can be altered, but it takes a lot of computing power to create refined, small refined meshes. So since I'm devoid of such computing power, I would like to restrict the size of the element to 0.02. Now, setting the boundary condition of static structure, I'd like to insert the standard earth gravity, which is of minus 0.8 meter per second square in the negative y direction. As in our case, I'd like to insert, I would like to now insert this boundary condition of fixed sum. Now we click on apply. You can see that fixed support has been applied. Then we insert the force, the load, as in our case. we applied a force of minus 1000 Newton. Now I'd like to proceed with the solution of deformation total, strain equivalent, stress equivalent, energy or strain energy. Like the computer to complete it and solve the following. So here is the part after the solution is what we call as pre-processing part. So here I have calculated, I've computed the total deformation. So here we can see that maximum deformation will be encountered in this red region, and then it will gradually decrease in yellow, green, and then blue region. I would like everybody to see the auto scale animation of the deformation that is going to take place, and also in true scale. That is the difference between auto scale and true scale total deformation. Now looking on to the elastic strain on true scale. Here it is how the elastic strain will develop, and on an auto scale, let us see the animation. Here is the equivalent elastic strain animation in auto scale. Next we look at equivalent stress. Here is the distribution, as you can see. In a true scale, here is the animation. In auto scale, this is the animation. Lastly, we look at the strain energy. In true scale, the animation looks somewhat like this, and in auto scale, this is how it looks like. So that was all from the analysis part. I would like to wind up. As you can see, the engineering data, we have a tick in all the 7 departments. So our analysis is complete in this for this part. So that was all I had to present. Thank you.